FortiGate 1 Firewall Policies. In this lesson, you will learn how to understand and apply the firewall policies to allow and deny traffic passing through FortiGate. At its core, FortiGate is a firewall, so almost everything that it does to your traffic is linked into your firewall policies. After this lesson, you should be able to properly identify the different components used in a firewall policy. You'll be able to configure and test your firewall policies, arrange them to correctly match traffic, and monitor traffic passing through them. To begin, let's talk about what firewall policies are. Firewall policies define which traffic matches and what FortiGate will do if it does. Should the traffic be allowed? This is decided first based on simple criteria such as the source. Then, if the policy itself does not block the traffic, FortiGate begins more computationally expensive security profile inspection, often known as Unified Threat Management, UTM, such as antivirus, application control, and web filtering, if you've chosen it in the policy. Those scans could block the traffic if, for example, it contains a virus. Otherwise, the traffic is allowed. Will NAT be applied? Authentication required? Firewall policies also determine that. Once processing is finished, FortiGate forwards the packet to its destination. FortiGate looks for the matching firewall policy from top to bottom, and, if a match is found, the traffic is processed based on that firewall policy. If no match is found, it is finally dropped by the default implicit deny policy. Each policy matches traffic and applies security by referring to objects that you've defined, such as addresses and profiles. What about other firewall policy types? Do IPv6 or virtual wire policies exist? Yes, and they use slightly different objects that are relevant to their type. In this lesson, we are discussing IPv4 firewall policies as they are the most common use case. Now we know what a firewall policy is. In this section, you will learn how FortiGate matches traffic with the firewall policies and takes appropriate action based on the matching policy. When a packet arrives, how does FortiGate find a matching policy? Each policy has match criteria, which you can define using these objects: ingress and egress, source and destination, such as IP address, device ID, or user, network service, such as IP protocol and port number, schedule, which applies during configure times, and action, either accept or deny. Once FortiGate finds a matching policy, it applies the configured settings for packet processing. Is antivirus scanning or web filtering applied? Will source NAT be applied? For example, if you want to block incoming FTP to all but a few FTP servers, you would define the addresses of your FTP servers, select those as the destination, and select FTP as the service. You probably wouldn't specify a source, often any location on the internet is allowed, or schedule, usually FTP servers are always available, day or night. Finally, you would set the action setting to accept. This might be enough, but often you'll want more thorough security. Here, the policy also authenticates the user, scans for viruses, and logs block connection attempts. To begin describing how FortiGate finds a policy for each packet, let's start with the interfaces. Packets arrive on an incoming or ingress interface. Routing determines the outgoing or egress interface. In each policy, you must set a source and destination interface, even if one or both are set to any. Both interfaces must match the policy's interface criteria in order to be a successful match. For example, if you configure policies between port 3, LAN, ingress, and port 1, WAN, egress, and a packet arrives on port 2, the packet would not match your policies and therefore be dropped due to the implicit deny policy at the end of the list. Even if the policy is from port 3, LAN, ingress, to any egress, the packet would still be dropped because it did not match the incoming interface. To simplify policy configuration, you can group interfaces into logical zones. For example, you could group port 4 to port 7 as a DMZ zone. Zones can be created from the Interfaces page. However, you should note that an interface in a zone cannot be referenced individually, and if you need to remove the interface from the zone, you must remove all references to that interface. For example, firewall policies, firewall addresses, and so on. If you think that you might need to reference interfaces individually, you should set multiple source and destination interfaces in the firewall policy instead of using zones. By default, you can only select a single interface as the incoming interface and a single interface as the outgoing interface. This is because the option to select multiple interfaces, or any interface in a firewall policy, is disabled from the GUI. However, you can enable the multiple interface policies under the Feature Select page to disable the single interface restriction. You can also select multiple interfaces, or any interface, if you configure a firewall policy from the CLI, regardless of the default GUI setting. It is also worth mentioning that when any interface is chosen, you cannot select multiple interfaces for that interface. In this example, because any is selected as the outgoing interface, you cannot add any additional interfaces. The next match criteria that FortiGate considers is the packet source. In each firewall policy, you must select a source address object. Optionally, you can refine your definition of the source address by also selecting a user, a group, or a specific device. If your organization allows bring your own device, then a combination of all three provides a much more granular match for increased security. Note that in FortiOS 5.4, when configuring the firewall address, you can allow the firewall address object name to be visible in a static route configuration, which can be used when configuring a static route. When selecting a fully qualified domain name as the source address, it must be resolved by DNS and cached in FortiGate. Make sure FortiGate is configured properly for DNS settings. If FortiGate is not able to resolve a fully qualified domain name address, it will present with a warning message, and a firewall policy containing a fully qualified domain name may not function properly. If a user is added as part of the source, it must be verified before allowing or denying access based on the firewall policy. There are different ways a user can be authenticated. For a local user, the username and password is configured locally on FortiGate. When a local user authenticates, it must match the username and password configured on the FortiGate locally. If it is a remote user, for example, LDAP or Radius, FortiGate receives the username and password from the remote user and passes this information to the authentication server. The authentication server verifies the user login credentials and updates FortiGate. Once FortiGate receives that information, access to the network is granted based on the firewall policy. A Fortinet single sign-on user authenticates by logging in with their username and password that is configured on the domain controller, and access is granted based on the group information on FortiGate. There are two device identification techniques, with an agent and without. Agentless uses traffic from the device. Devices are indexed by their MAC addresses, and there are various ways to identify devices, such as HTTP user agent header, TCP fingerprint, MAC address OUI, DHCP, Microsoft Windows Browser Service, SIP user agent, link layer discovery protocol, and simple service discovery protocol. Note that FortiGate uses first come, first served to determine the device identity. For example, if a device is detected by the HTTP user agent, FortiGate updates its device table with the detected MAC address, and scanning stops as soon as the type has been determined for that MAC address. Agent-based uses FortiClient. FortiClient sends information to FortiGate, and the device is tracked by its unique FortiClient UID. If you enable source device type in the firewall policy, FortiGate enables device detection and active scanning on the source interfaces of the policy. By default, FortiGate uses device detection, passive scanning, which runs the scans based on the arrival of traffic. What is active scanning? If passive detection fails to detect the device type for over 5 minutes, active scanning is triggered and scans every 3 minutes. If active scanning fails to detect the device type, the next scan occurs 10 minutes later. If that scan fails, the next occurs 15 minutes later. FortiGate uses an n+1 times 5 minutes algorithm for scanning, where n is the number of scans that have been done. Active scanning scans for device type, OS, and OS version. The device list shows the list of detected devices. It also shows the number of devices detected. You can right-click on any detected device to edit, delete, or view details in FortiView. The details include session, destination, policies, and more. You can also define static entries for device and/or device groups. By default, devices are grouped into custom device groups. However, if a predefined device group doesn't match your organizational needs, you can create a custom group. Devices are indexed by MAC and identified from multiple sources. The CLI command diagnose user device list shows a more detailed listing than the device inventory page, including the detection method. In this worked example, devices are detected by source as TCP fingerprinting, HTTP user agent, and FortiClient. Detected devices are saved to FortiGate's flash drive. Therefore, on restart, FortiGate knows that devices have already been identified and does not have to recategorize each device. The user displayed in the device information is just a tag. It cannot be used as a means of identification for an authentication policy. FortiGate can control FortiClient settings through the FortiClient profile and registration. In order for FortiClient to register with FortiGate, FortiTelemetry must be enabled on the applicable interface. There are other configuration settings worth mentioning, such as enforce FortiTelemetry for all FortiClients. If enabled, non-compliant devices are blocked and redirected to a web portal that explains the non-compliance and provides a link to download FortiClient. You can exempt devices from FortiClient enforcement using source and/or destination or services. Once FortiClient is registered, it is added into the device list. FortiGate also pushes the FortiClient profile to the registered FortiClient. You may configure the default FortiClient profile or add additional profiles. You can also view the FortiClient endpoint information from the FortiClient monitor page. You can run diagnose user device list or diagnose endpoint registration list to view the FortiClient unique UID. FortiClient devices have a unique ID which can be used as an index for the device. The unique ID is used instead of the MAC address because using MAC addresses can be problematic when a device has multiple MAC addresses, such as servers or virtual machines, or when there is no layer 2 visibility of the device. The License Information widget on the FortiGate GUI dashboard shows the total number of registered devices and the total number of devices available for registration. Windows and Mac OS X FortiClient installers are also available from this dashboard widget. FortiClient is the agent-based approach for source device type. As shown in the previous slide, FortiClient enforcement is enabled on the interface. Firewall policies with this source interface will force the user to download or register FortiClient with FortiGate. In FortiOS 5.2, FortiClient enforcement was enabled on a policy-by-policy basis. Here, all 3 source selectors identify the user group, device type, and specific subnet. Remember, user and device are optional objects. They are used here to make the policy more specific. If you wanted the policy to match more traffic, you would leave the user and device objects undefined. Like the packet source, FortiGate also checks the destination address for a match. Address objects may be a hostname, IP subnet, or range. If you enter a fully qualified domain name as the address object, make sure that you've configured your FortiGate with DNS settings. FortiGate uses DNS to resolve those fully qualified domain name host names to IP addresses, which are what actually appear in the IP header. Geographic addresses, which are groups or ranges of addresses allocated to a country, can be selected instead. These objects are updated via FortiGuard. Why is there no option to select users or devices? The user identification or device identification is determined at the ingress interface, and packets are forwarded only to the egress interface once user or device authentication is successful. Schedules add a time element to the policy. For example, a policy allowing backup software may activate at night, or a remote address may be allowed for testing purposes, and a schedule provides a test window. Schedules can be configured from the Schedules page and use a 24-hour time clock. There are a few configuration settings worth mentioning. Recurring. When configuring recurring schedules, if the stop time is set earlier than the start time, the stop time will occur the next day. For example, if you select Sunday as the day, 10 o'clock as the start time, and 9 o'clock as the stop time, the schedule will stop on Monday at 9 o'clock. If the start and stop time are identical, the schedule will run for 24 hours. One time. The start date and time must be earlier than the stop date and time. You can also enable pre-expiration event log, which will generate an event log n number of days before the schedule expires, where n can be from 1 to 100 days. Another criterion that FortiGate uses to match policies is the packet service. At the IP layer, protocol numbers, for example, TCP, UDP, SCTP, and so on, together with source and destination ports, define each network service. Generally, only a destination port, that is, the server's listening port, is defined. Some legacy applications may use a specific source port, but in most modern applications, the source port is randomly determined at transmission time and therefore is not a reliable way to define the service. For example, the predefined service object named HTTP is TCP destination port 80, and the predefined service object named HTTPS is TCP destination port 443. However, the source ports are ephemeral and therefore not defined. By default, services are grouped together to simplify administration, so you can view the services by category or alphabetically. If the predefined services doesn't meet your organizational needs, you can create one or more new services, service groups, and categories. So far, we have learned about Firewall Policy's matching criteria and the action that FortiGate can take. In this section, you will learn how to configure firewall policies. When you configure a new firewall policy from the GUI, you must specify a unique name for the firewall policy because it is enabled by default, but optional in the CLI. This helps the administrator to quickly identify the policy that they are looking for. However, you can make this feature optional in the GUI from the Feature Select page by enabling Allow Unnamed Policies under Additional Features. When upgrading from a previous FortiGate firmware version, for example 5.2, or a policy configured from the CLI, no policy names are assigned. However, if you modify an existing policy from the GUI, you must specify a unique name. The FortiGate Flat GUI view allows you to select interfaces and other objects by clicking or dragging and dropping on the list populated on the right-hand side. There are many other options that you can configure from the firewall policy, such as firewall and network options, security profiles, logging options, and enabling or disabling a policy. When creating firewall objects or policies, a universally unique identified attribute, UUID, is added so that the logs can record these UUID and improve functionality when integrating with FortiManager or FortiAnalyzer. When creating firewall policies, remember that FortiGate is a stateful firewall. As a result, you only need to create one firewall policy that matches the direction of the traffic that initiates the session. FortiGate will automatically remember the source-destination pair and allow replies. One of the most important features that a firewall policy can apply is security profiles, such as IPS and antivirus. A security profile inspects each packet in the traffic flow, where the session has already been conditionally accepted by the firewall policy. When inspecting traffic, FortiGate can use one of two methods, flow-based or proxy-based. Different security features are supported by each type. You can also enable learning mode on a firewall policy. When you set action to learn, the firewall policy automatically applies default static profiles and passes traffic to security profiles for monitoring. It also enables logging with full capabilities, which are tagged as learning in the logs. You can view the comprehensive report that results from learning mode under the Learning Reports page. This report uses all of the learning logs across all traffic and security vectors to generate a complete summary report. This enables users to easily implement a monitor then enforce process. If you enable Generate Logs when session starts, FortiGate will create a traffic log when the session begins. But remember that increasing logging decreases performance, so use it only where necessary. If you have enabled logging in the policy, FortiGate will generate traffic logs once a firewall policy closes an IP session. During the session, if a security profile detects a violation, FortiGate will record the attack log immediately. To reduce the amount of log messages generated and improve performance, you can enable a session table entry of dropped traffic. This creates the denied session in the session table, and, if the session is denied, all packets of that session are also denied. This option is in the CLI and is called SES Denied Traffic. You can also set the duration for blocked sessions. This determines how long a session will be kept in the session table by setting Block Session Timer in the CLI. By default, it is set to 30 seconds. If the GUI option Generate Logs when session starts is not displayed, this means that your FortiGate device does not have internal storage. This option is in the CLI, regardless of internal storage, and is called Set Log Traffic Start Enable. Two types of traffic shapers can be configured, shared and per IP. A shared shaper applies a total bandwidth to all traffic using that shaper. The scope can be per policy or for all policies referencing that shaper. FortiGate can count the packet rates of ingress and egress to police traffic. In FortiOS 5.4, traffic shaping policies are created separately on the Traffic Shaping Policy page. FortiGate allows you to create three types of traffic shaping policies. Shared policy shaping, which is bandwidth management of security policies. Per IP shaping, which is bandwidth management of user IP addresses. And application control shaping, which is bandwidth management by application. When creating traffic shaping policies, you must ensure that the matching criteria is the same as the firewall policies you want to apply shaping to. Note that these apply equally to TCP and UDP protocols may not recover as gracefully from packet loss. So far, you have learned how to configure firewall policies. In this section, you will learn how to manage and fine-tune settings for firewall policies. Firewall policies appear in an organized list. It's either organized in interface pair view or by sequence. Usually it will appear in interface pair view. Each section contains policies for that ingress-egress pair. Alternatively, you can view your policies as a single, comprehensive list by clicking By Sequence at the top of the page. In some cases, you won't have a choice of which view is used. If you use multiple source and destination interfaces, or the Any interface in a firewall policy, policies cannot be separated into sections by interface pairs. Some would be triplets or more. So instead, policies are then always displayed in a single list, by sequence. To help you remember the use of each interface, you can give them aliases. For example, you could call port 3 internal network. This can help to make your list of policies easier to comprehend. Firewall policies in the GUI are ordered primarily by the policy sequence number. Policy sequence numbers define the order in which rules are processed. Policy IDs are identifiers. By default, sequence numbers are displayed on the GUI. CLI commands, however, use policy ID. Be careful not to accidentally modify the wrong policy. To avoid such errors, you can add the policy ID to the GUI using the column Settings. Remember that we mentioned that only the first matching policy applies? Moving your policies into the correct position is important. It affects which traffic is blocked or allowed. In the applicable interface pairs section, FortiGate will look for a matching policy, beginning at the top. So usually you should put more specific policies at the top. Otherwise, more general policies will match the traffic first, and your more granular policies will never be applied. Here, we're moving a policy, sequence number 3, ID 8, that only matches syslog traffic above a more general full access policy, accept everything from anywhere. Otherwise, FortiGate would always apply the first matching policy, full access, and never reach the block syslog policy. Notice that after moving this policy up, the sequence number changed from 3 to 2, but the policy ID 8 remained the same in the GUI. As the CLI only uses policy ID, before moving, policy ID 7 was on top, and after the move, policy ID 8 is on the top. As a best practice, always add the policy ID column in the GUI. While sequence number changes when a policy is moved, the value that remains with a policy is the policy ID. To reduce the total number of firewall policies in RAM and to simplify administration, you can group service and address objects. Then, you can reference that group in the firewall policy instead of selecting multiple objects each time or making multiple policies. Here, we see 4 services that match the policy: HTTP, HTTPS, FTP, and DNS. DNS is usually used by HTTP, as people remember domain names for websites instead of their IP addresses. If you need to make many policies for web and FTP traffic, then it makes sense to create a service object named Web FTP. That way, you don't have to manually select all 4 services each time you make a policy. Policies can reference the Web FTP service group instead. Also, if you notice, you can consolidate these 2 firewall policies, as they have the same source and destination, except the services are different. You can consolidate source address as source group and create a service group containing all the services for web, FTP, and email access. When consolidating 2 firewall policies, the other settings in the firewall policy, such as logging and security profiles, should match. We've just shown several component objects that can be reused as you make policies. But what if you want to delete an object? If it's being used, you can't. First, you must reconfigure the objects that are currently using it. The GUI provides a simple way to find out where in the FortiGate's configuration an object is being referenced. See the numbers in the ref column? They are the number of places where that object is being used. The number is actually a link, so if you click it, you can see which objects use it. In this example, address all is being used by an address group and 2 firewall policies. If you select a firewall policy, you can use the Edit, View List, and View Properties tabs. Edit. It allows you to edit the selected object. In this example, it shows the edit page for the Firewall Policy ID 3. View List. It allows you to view selected objects in its category. In this example, it will show you the list of all the firewall policies. View Properties. It shows where the object is used in that configuration. In this example, address object all is being used in the destination address and source address of that firewall policy. You can right-click any firewall policy sequence to see different menu options to edit or modify the policy. The options include enabling or disabling a firewall policy, inserting firewall policies, either above or below, copying and pasting policies, and cloning reverse, only if NAT is disabled on that policy. Clicking Edit in CLI opens the CLI console for the firewall policy or object selected. Right-clicking the objects provides you with options to add or remove an object of the same type, modify an object, and show a reference for that object. So far, we have learned about managing firewall policies. In this section, you will learn how to monitor and find matching firewall policies using the Policy Lookup feature. In FortiOS 5.4, you can find a matching firewall policy based on the Policy Lookup input criteria. It is basically creating packet flow over FortiGate without real traffic, from which it can extract a policy ID from FlowTrace and highlight it on the GUI policy configuration page. Depending upon the protocol you select, for example, TCP, UDP, IP, ICMP, and so on, you need to define other input criteria. For example, when you select TCP as a protocol, you need to define the source address, source port, which is optional, destination port, and destination address. When you select ICMP as a protocol, you need to define the ICMP type and code, source address, and destination address. When FortiGate is performing policy lookup, it performs a series of checks on ingress, stateful inspection, and egress for the matching firewall policy from top to bottom before providing results for the matching policy. Note that if the firewall policy status is set to disable, the policy lookup skips the disabled policy and checks for the next matching policy in the list. Based on the input criteria, after clicking Search, the trace result will be selected and highlighted on the IPv4 policy page. To review, here's all the topics we covered in this lesson. How packets match a firewall policy, how FortiGate defines matching traffic, configuring firewall policies, reordering policies to match more granular policies first, and using policy lookup to find matching policies.